Session 7, Legendre's equation. Now we are going to see the definition of Legendre equation. Another important differential equation used in problems showing spherical symmetry is Legendre's equation given by 1 minus x square d square y by dx square minus 2x dy by dx plus n into n plus 1 into y equal to 0. Here n is a real number, though in most practical application only non-negative integral values are required. Series solution of 1 in terms of Legendre's function Pn of x and Qn of x is given by y is equal to a into Pn of x plus b into Qn of x, where Pn of x is equal to 1 into 3 into 5 etc. up to 2n minus 1 by n factorial into x power n minus n into n minus 1 by 2 into 2n minus 1 into x power n minus 2 plus etc. Pn of x is a terminating series containing the positive powers of x. So here the Pn of x, all the values coefficient of x power x is the positive powers. Next, what is it? Qn of x equal to n factorial by 1 into 3 into 5 etc. to n plus 1. So just the reciprocal of Pn of x. So x power minus n minus 1 plus n plus 1 into n plus 2 divided by 2 into 2n plus 2n plus 3 into x power minus n minus 3 plus n plus 1 n plus 2 n plus 3 n plus 4 divided by 2 into 4 into 2n plus 3 into 2n plus 5 into x power minus n minus 5 etc. Qn is a non-terminating series containing negative powers of x. Pn is a positive powers of x. Qn is a negative powers of x. So now we are going to see the problems. Generating function for Pn of x. Now we are going to calculating the generating function. The function 1 minus 2xz plus z square whole power minus 1 by 2 is called the generating function of the Legendre's polynomial, as 1 minus 2xz plus z square whole power minus 1 by 2 equal to summation n is equal to 0 to infinity Pn of x into z power n. So we are going to see the proof of this generating function. So consider the left hand side. 1 minus 2xz plus z square whole power minus 1 by 2 equal to 1 minus of. So combining these two terms, so here take out the minus outside. So can be written as 2xz minus z square whole power minus 1 by 2. So this we have to expand by using the binomial expansion. This is of the form 1 minus x whole power minus 1. So what is the formula for 1 minus x whole power minus 1? 1 plus x square plus x cube plus etc. So likewise here uses 1 plus 1 by 2 into 2xz minus z square plus 1 by 2 into 3 by 4 2xz minus z square the whole square plus etc. plus 1 by 2 into 3 by 4 2k minus 1 by 2 2xz minus z square into k plus etc. So this is the expansion of this formula. They give equal to 1 plus summation. So this we have to expand by the power series. Summation x is equal to 0 to infinity. 1 by 2 into 3 by 4 is common for all the term. In the last term we have a 2k minus 1 by 2 into 2xz minus z square whole power k. So here we have to consider 2xz minus z square whole power k is equal to. So from these two terms, take out the z outside. So we can write z power k into 2x minus z whole power k. So here 2x minus z the whole power k can be written as 2x whole power k minus k into 2x whole power k minus 1 into z plus k into k minus 1 by 2 factorial 2x into whole power k minus 2 into z square plus etc. plus minus 1 the whole power k into z power k. Okay, using the 2 in equation number 1. So instead of this 2k z minus z square whole power k, so we can substitute this as this term fully we have to substitute. Then we get the result 1 plus summation k is equal to 0 to infinity 1 by 2 3 by 4 etc. 2k minus 1 by 2k into write that summation fully here. Then the coefficient of z power n in the expression 3 is given by 1 by 2 into 3 by 4 2n minus 1 by 2n into 2x whole power n. That is equating the coefficient of z power k. Then the second term minus 1 by 2 3 by 4 2n minus 3 by 2 n minus 2 n minus 1 into 2x whole power n minus 2 etc. likewise. So this fully they taken as p n of x. So therefore 1 minus 2x z plus z square whole power minus 1 by 2 equal to summation n is equal to 0 to infinity p n of x into z power n. Note, this is a corollary. P n of 1 is equal to 1 and p n of minus 1 is equal to minus 1 whole power n. So we are going to see the proof of this two corollary terms. That is, consider the generating function 1 minus 2xz plus z square whole power minus 1 by 2 is equal to summation n is equal to 0 to infinity p n of x into z power n. So here put n x is equal to 1 on the both the sides. So we get 1 minus 2az plus z square whole power minus 1 by 2 equal to summation n is equal to 0 to infinity p n of 1 into z power n. So here we can subtract here, that is this can be expanded as 1 minus z the whole power 2. That is we know the formula for a minus b the whole square, a square plus b square minus 2ab. So likewise 1 minus z the whole square expansion is 1 minus 2z plus z square. So already power we have minus 1 by 2 having. So just adding we will get the whole power minus 1 equal to summation n is equal to 0 to infinity p n of 1 into z power n. So now expand this one by using the binomial expansion. We get 1 plus z square plus etc. z power n equal to summation n is equal to 0 to infinity p n of 1 into z power n. So now here for this one can be written as summation n is equal to 0 to infinity z power n equal to summation n is equal to 0 to infinity p n of 1 into z power n. Now we are going to equating the like coefficient of z power n. So we get p n of 1 is equal to 1. So likewise, putting x is equal to minus 1 on both the sides of equation 1. So we can write 1 plus 2z plus z square whole power minus 1 by 2 equal to summation n is equal to 0 to infinity p n of minus 1 into z power n. So here they wrongly here they didn't put the minus 1 but here put the minus 1. Now this is of the form a plus b the whole square, that is 1 plus z the whole square. Then combining with minus 1 by 2, so we will get the minus 1 equal to summation n is equal to 0 to infinity p n of minus 1 into z power n. So now expand this one, we will get the alternative plus minus sign symbol, then equal to summation n is equal to 0 to infinity p n of minus 1 into z power n. So now this left hand side can be written as summation n is equal to 0 to infinity minus 1 the whole power n into z power 1. If you give the any value for n, if you substitute n is equal to 0, anything power 0 value is 1. Then apply n is equal to 1, you will get the minus z. N is equal to 2, if you apply plus z square. Likewise, you will get. So now we have to equate the coefficient of z power n on both the sides. Can be written as p n of minus 1 is equal to minus 1 the whole power n. Now we are going to see the recurrence relation of Legendre's equation. So first relation, n plus 1 into p n plus 1 of x is equal to 2n plus 1 of x into p n of x minus n into p n minus 1 of x. So now we know the generating function 1 minus 2xz plus z square whole power minus 1 by 2 equal to summation n is equal to 0 to infinity z power n into p n of x. So now differentiate this generating function with respect to z. So we will get, so first term here first we have to differentiate the power. So n into, this is the form x power n. So differentiation of x power n is n into x power n minus 1. So minus 1 by 2 into 1 minus 2xz plus z square minus 1 by 2 minus 1 can be written as minus 3 by 2 into differentiation of this inside the bracket term. So for differentiation of 1 is 0, then the differentiation of this one is minus 2x, then the differentiation of z square is 2z, that is minus 2x plus 2z equal to this side differentiate. So here n into z power n minus 1 into p n of x. So now, so from these term we can take out the minus 2 of x, minus 2 outside. So this minus minus cancel, 2 will cancel. So remaining we'll get x minus z into 1 minus 2xz plus z square whole power minus 3 by 2 can be written as minus 1 by 2 minus 1 equal to the right hand side right as it is. So now we have to multiply the both the sides by 1 minus 2x plus z square on the both the sides. So we get x minus z into 1 minus 2xz plus z square, that minus 1 will cancel, equal to 1 minus 2xz plus z square into summation n is equal to 0 to infinity n into z power n minus 1 into Pn of x. So now here this one can be written as by using the generating function. So instead of 1 minus 2x plus z square whole power minus 1 by 2 can be written as summation n is equal to 0 to infinity z power into Pn of x, z power into Pn of x equal to 1 minus 2xz plus z square summation n is equal to 0 to infinity n into z power n minus 1 into Pn of x. Okay, so using one, we got the result this one. So now, before going to equating z power n, so we will see the expansion of this one. So now, multiplying this term, that is here we have x minus z into summation n is equal to 0 to infinity z power n Pn of x having no. So this all the term you multiplying, so you will get the result as x into summation n is equal to 0 to infinity z power n Pn of x minus summation n is equal to 0 to infinity z power n plus 1 into Pn of x plus equal to summation n is equal to 0 to infinity n into z power n minus 1 Pn of x minus 2x into summation n is equal to 0 to infinity n into z power n Pn of x plus summation n is equal to 0 to infinity n into z power n plus 1 into Pn of x. So now equating the coefficient of z power n, so that is before that here we should have a z power n only we have. So for that we have to add and subtract the 1. So we can write n plus 1 minus 1. So here also replace n minus 1. Same way here we have to should get the z power n. So add the plus 1. So we'll get the n plus 1 into z power n minus 1 plus 1. Here suffix also had n plus 1. Then minus, so here the minus will come. So I'm having mistake. So minus 2x into, so this term write as it is. Then plus summation n is equal to 0 to infinity. So here also you should the 1 minus 1 and subtract. So n minus 1 into z power n plus 1 minus 1. Here the suffix p n minus 1 of x. So now we have to combine the z power. Now only you have to equate the z power n term. So here we have x into Pn of x. Here written x into Pn of x. So here where we have the z power n term. In the same way here we have that is a minus Pn this term. That is the last term we have the Pn minus 1. Pn minus 1 of x equal to, here we have n plus 1 into Pn plus 1 of x minus 2x n into, this is Pn of x plus n minus 1 into Pn minus 1 of x. So which is equal to, so now write this term Pn n plus 1 into Pn plus 1 of x as it is. Then these two terms have to add. So from these two terms we can take out the x outside. Then Pn of x is also outside. So can be written as 1 plus 2n. Then Pn minus 1 of x into, then bring the this term to the side, we can write n minus 1 plus 1. So now plus 1 minus 1 will cancel, only we will get the n here. So which is implies n plus 1 into Pn plus 1 of x equal to x into Pn of x into 1 plus 2n minus n into Pn plus 1 of x. So we got the result n plus 1 into Pn plus 1 of x equal to 2n plus 1 into x into Pn of x minus n into Pn minus 1 of x. So that is a proof of the first relation. Next we go for the second relation. So Pn of x is equal to Pn plus 1 dash of x minus 2x into Pn dash of x plus Pn minus 1 dash of x. So now we know the generating function. So generating function differentiate on the both the sides. So we get the result like this. So here that is we are differentiating with respect to x. So previous relation we have to differentiate with respect to z, but here we are differentiating with respect to x. So therefore we get the minus 1 into 1 minus 2xz plus z square minus 1 whole power minus 1 by 2 into differentiation of this one is, we'll get the minus 2z. Then this term Pn dash of x will get. So multiplying all these terms we get that. Now equating the coefficient of z power n plus 1. So we should have a z power n plus 1. So first term we have a z power n plus 1 having. So second term we have to add n plus 1, then subtract n plus 1. So finally we get the result Pn of x equal to Pn plus 1 dash of x minus 2x into Pn dash of x plus Pn minus 1 dash of x. That's all. We will see in the next class.